Good morning, Cappuccino. Here are some helper videos to help you with the related rates Mathspace assignment. This is problem number 6. So problem number 6, you have an ice sculpture that's in the shape of a cube, and you might have a different side measure. This one says 2 meters, but you might have something else. So notice though it is in meters. And then down below, it says that the sculpture is melting in such a way that it retains the shape of a cube, which is insane. That would not happen, but okay. So let V represent the volume of ice remaining. And notice that it says cubic centimeters, okay? So the first thing you want to do is change this 2 meters up here. You want to change that to centimeters. So instead of 2 meters, in centimeters, that would be 200 centimeters. So that's like the biggest thing to pay attention to. So X represents the side length of the ice cube in centimeters at time t seconds after it starts being heated. Okay, so I'm actually making some notes right now, and I'll show you my notes in a minute, but I'm going to have a side length of X, and I know volume. I'm going to have to deal with volume. Okay, let's see what else we got. If the length of each edge is decreasing by 0.06 centimeters per second, so you notice that? It's changing in centimeters per second. The length of each edge is decreasing, so length over time, okay, centimeters per time. So that means that is my dx dt, how the length is changing over time. Dx dt is equal to 0.06 with no variables. Okay, it's just a constant. Find the initial rate at which the volume of the cube is changing in cubic centimeters per second. So I'm trying to find dV dt. How is it changing in cubic centimeters per second? So per second, that means that's time. So I want to find dV dt. Okay, so I have dx dt. I'm trying to find dV dt. I also know volume of a cube. I can write that as x cubed. Volume of a cube is equal to x cubed. Okay, so I've written down all my information on a piece of paper. So now I'm going to see if I can share that with you. And hopefully this all goes well. So I'm now sharing my dock camera. There we go. So related rates, question number 6. My problem says 2 meters is the side length. That's x. X is equal to 2 meters, which is 200 centimeters. So x is equal to 200. Okay, x is equal to 200. Volume is x cubed because it's just a cube. The change in x over time is 0.06, and I'm asked to find dV dt. So you know this is a related rates question, so I'm looking for some things I can multiply together to end up with dV dt. Well, the obvious thing to do would be to take the derivative of volume. So dV dx is what I would end up with. If I take the derivative of volume here, notice it's v in terms of x, so it's going to be dV over dx. So if I take the derivative, I get 3x squared. So now if I take dV dx and I multiply it by dx dt, I'll end up with dV dt. So I'm going to have my dV dx times dx dt. Notice the dx's are going to cancel out, and I will be left with dV dt, which is what I needed. Oh, one thing I almost forgot, super critical, because when I first did this problem, I got it wrong, and I couldn't understand why. It's decreasing. The side length is decreasing. So you notice how I put dx dt is 0.06. It's negative 0.06. It's not getting bigger. It's getting smaller. So for it to lose volume, this has to be negative. So that was the critical thing I did wrong when I first tried this problem, and I didn't get it right. So 2 things that are really critical: change to centimeters and make sure your rate of change here is negative. Okay, so now dV dx is 3x squared. I'm going to times that by dx dt. Dx dt is negative 0.06. And remember, these numbers probably vary on your problem, so be careful about that. And that will give me my dV dt. And then on my problem, I think it said for what value of x I'm supposed to be evaluating it for. Or no, it's initially. So that would be x is equal to 200. So my x is going to be 200. So I'm going to go 3 times 200 squared times negative, now let's put it in parentheses, negative 0.06. That should give me my dV dt. So before I bother taking out my calculator, I can go ahead and go back to Mathspace. So let's see, where's my Mathspace? And let's go ahead and just type in what I just wrote down on my paper before I bother getting out my calculator. Let's make sure that's right. So dV dt, and you need to use capital letter V, is equal to 3 times 200 squared times negative 0.06. That should do it. Let's see if I'm doing okay. Yes. All right. So then I just need to multiply it out and I'll have my right answer. So let me go ahead and multiply that out. Sorry, I don't have this done ahead of time because when I first did the problem, I had different numbers. Then when I did it again, so I'm just entering this in. Times negative 0.06. Negative 7,200. So let me write that in. Negative 7,200. Oh no, I forgot the negative sign. See, that always happens, right? It's always a negative. All right, now the volume is decreasing at a rate of 300 centimeters cubed per second. Find the initial rate at which the length of each edge is changing. Okay, so now they're changing up the problem on us. It's not changing at what it was in the first problem. So now I don't know the dx dt. Find the initial rate at which the length is changing in centimeters per second. So that is going to be dx dt. So I don't know dx dt for this second part. I do know that the volume is decreasing. And notice that word decreasing. Okay, it's decreasing at this rate. So that's my dV dt. Now I know dV dt, and it's equal to negative 300. So make sure you're writing down that negative sign. Okay, decreasing is negative. So I know the dV dt. I'm trying to find the dx dt, and I still know dV dx because that's just from the formula for volume. So let me go back to my document camera. And let's put that together. Here we go. So for part B, I'm trying to find dx dt. I know dV dt is negative 300. And from the previous problem, I know dV dx is equal to 3x squared, because that's just the derivative of volume. Oh, let me hide this floating bar. There we go. So dV dx, I can just borrow it from there. So now if I put these together, if I multiply them, I'm not going to end up with this. So what I need to do, it looks like I'm going to have to divide them because I want the x to be on top and the t to be on the bottom. So I'm going to have dv dt divided by, let's see, I'm hanging off the bottom here, divided by dv dx. Because when I divide, I change that to multiplying by the reciprocal. And the dv's go away, and I'll be left with dx dt. Okay, so dv dt I know is negative 300. And I'm going to multiply that by the reciprocal of dv dx. So I'm going to multiply that by 1 over 3x squared. So I'm going to get, let's see, 300 divided by 3, that's going to be negative 100 over x squared. And my x was 200. Okay, how much was I starting with? So I was starting with 200. So let me go ahead and put this in, though, to Mathspace. Make sure I'm going okay. So let's go back to Mathspace. I'm going to say that my dx dt is equal to negative 100 divided by x squared. Let's see if I'm on the right track. Yep, I'm on the right track. So now I just need to put in my measurement, my length measurement, which was 2 100, right? Because I changed the meters to centimeters. Let's see if I'm still doing okay. Yep, I'm still doing okay. So then if I multiply this out, I could probably do it by hand, but I'm not going to, just to be safe. 100 divided by 200 squared is 0.0025. So I'm going to change this to negative, don't forget the negative, 0.0025. Okay, and don't forget the 0 in front of the decimal point because this is Desmos. And voila, there it is. Okay, that's problem number 6. In the next video, I will do problem number 7.